Hi, I'm Brandon Gracely. I'm a high school math teacher. We're looking at solving linear systems by elimination, and let's look at the special cases where we end up with parallel lines. And parallel lines can be distinct, so they're next to one another but different, or they can overlap. They can be identical, where there's one line drawn sort of right on top of the other. So let's look at a couple of examples. Here's one. There's a line. And here's another line which happens to be parallel to it. And we'll see whether it is a pair of distinct lines or whether the two lines are identical. And everything starts off in the same way. If x1, y1 is an intersection point, then what must be true? Well, x1, y1 must be on this line and on this line. Because it's on the first line, we have this must be true at that point. And we must also have that the equation is true, the second equation is true at that same point. Now these equations are really close to one another because, look, if I multiply the top one by 2, I'll end up with the same coefficient and opposite sign as the bottom one for the x term. So I'm going to do that, multiply by 2, and the bottom one I'll leave alone. So the top one I get 4x1 minus 2y1 plus 10 equals 0. And for the bottom equation, I'm going to leave it as it is. Okay, and so now I have two equations. If I add them together, it will eliminate this variable here. I'll end up with 0x1. There's the elimination step. And now I've got negative 2y1 plus 2y1. That's 0y1. And then over here I have plus 9 equals 0. Or let me just rewrite that. 9 equals 0. That is not a true statement. This is false for all values of x1 and y1. So if I choose a point on the line, on one of the lines, then it's an intersection point if this is true. This is not true, so we must not be able to find an intersection point. So the two lines, I'll say it this way, there is no intersection point. And that is because the two lines are parallel, but they are distinct. Okay, well, I guess you can figure out what's going to come next. What if I have these two lines? That might look familiar. Okay, so just like before, we have if we can find some intersection point, x1, y1, then what must be true? x1, y1 must be on the first equation, on the first line, which means it satisfies the first equation. So that must be true. And also, this must be true. Well, just like last time, I noticed that I can sort of double the first equation and get a matching coefficient with the opposite sign. So I'll have 4x1 minus 2y1 plus 10 equals 0. 5 times 2 is 10. And the second one I'm going to leave as is, or multiply it by 1 if you like. Oh, missed my 1 there. Okay, two equivalent equations, the same as these two here. I'm going to add them together. Here I'll get 0x1 plus 0y1 plus 0 equals 0. Look at that, 0 equals 0. That is always true. If I choose a point that's on one of the lines, it's an intersection point. So that means that the lines are equivalent, or you can say they're identical. And you might say this, and there are infinitely many intersection points. Okay, so once again, the three things that can happen: two lines can cross in a point, that is if they are not parallel. If they are parallel, they can run next to one another and be the same distance apart at all times, so they never cross. Or they can be the same line, which means every point all the way along it, every point is an intersection point, and there are infinitely many of those. Okay, I hope that helps, and let me know if you have any questions. Thanks.